Okay, um, moving on with the revision of basic linear equations. E is an example of a double-sided equation where we've got x's on both sides. So remember, whenever we want to solve an equation, we want all of our x values on one side and all of our numerical values on the other side. It doesn't really matter which side x is on, but convention, because in this country we read from left to right, I tend to read equations from left to right. So we tend to have the x on the left hand side. So for this, 6x plus 5 is equal to 2x plus 9. I'm going to take the 5 over to the right hand side, and I'm going to take the 2x over to the left hand side. That will give me 6x that's already there. Take away 2x is equal to the 9 that's already there. Take away 5. When I write out my equations, no matter what level of equations I've got, I always start by writing out the values that are already on the side, and then anything that moves goes after it. So 6x take away 2x gives me 4x is equal to 9 take away 5, which is 4. So x has to be 1. Example F, 10x take away 3 is equal to 7x minus 12. Again, same process. Take the 7x over to the left hand side, and we'll take the minus 3 over to the right hand side. So that'll give me 10x take away 7x is equal to the minus 12 that's already there, and then the minus 3 becomes a plus 3. So 10x take away 7x would give me 3x is equal to minus 12 plus 3, which is minus 9. So 3x is minus 9, divide both sides by 3, so we get x is equal to minus 3. Example G combines our work on solving equations with brackets along with them being double-sided equations. So let's just put them together. We have to expand the brackets here in order to solve. So take it one step at a time. The 3 multiplies the first bracket, so I get 3k plus 6. The minus 5 here, remember, it's minus 5, not plus 5. The minus 5 multiplies the second bracket, and it gives me minus 5k minus 5. Watch out for that devious and evil hidden negative there. And that is equal to k plus 4. So in this case, I want all my k's on one side and all my numbers on the other side. So it gives me 3k, take away 5k, minus k is equal to 4 plus 5 minus 6. Remember, change side, change sign. Right, so 3k take away 5k is minus 2k. Take away k is minus 3k. Is equal to 4 plus 5 is 9. Take away 6 is 3. So minus 3k is equal to 3. Therefore k has to be, divide 3 by minus 3, we get minus 1. The last example in this section just now, we want to solve these equations. Now, we're going to have to do a little bit of expanding before we start moving things about. This example here is a very good example to allow you to organise your thoughts and organise the work that you've got in front of you here, because there's quite a lot involved in this. So in order to allow us to solve the equation, we're going to have to expand the FOIL brackets here. So Well, let's go to the side and do our expansion. So the first thing I've got here is x plus 3 all squared. Now, from your knowledge of expanding brackets, you should remember that this means x plus 3 times x plus 3. We covered this before school closure. So x plus 3 times x plus 3. So all I'm going to do is I'm going to FOIL this out. X times x gives me x squared. 3 times x plus 3 times x. So it's 3x plus 3x. And then 3 times 3 is 9. So if you're doing it at the same time as me, you should get x squared plus 6x plus 9. And it's the exact same with the x plus 2 all squared. So if I was to expand x plus 2 all squared, that's the same as saying x plus 2 times x plus 2, and then we'll just FOIL that out. So that will give me x squared plus 2x plus 2x plus 4. Sorry for it cutting off a wee bit there. Which gives me x squared plus 4x plus 8. And that's really the most difficult part of this question here. It's just getting you to take your thoughts, what you need to expand, go to the side, expand it, and now we're just going to bring back these answers back into the main body of our work here. So that's going to give me x plus 3 all squared, we know is going to give us x squared plus 6x plus 9. That was equal to x squared plus 4x plus 4, and then we're adding 9 on at the end. Apologies, I've moved this down just to give me a bit more room to work. So let's move the variables across. So I want all the x's on one side, all the numbers on the other side. So I get x squared, take away x squared, plus 6x, take away 4x, is equal to the 4 that's already there, plus the 9 that's already there, and then take away the 9 that we're bringing over from the left hand side. So x squared take away x squared, that just cancels out. 6x take away 4x gives me 2x, is equal to 4 plus 9 take away 9, which just gives me 4. So 2x is equal to 4, divide both sides by 2, so x is equal to 2. And that is your recap of solving simple linear equations.